going on, guys? Welcome back to the channel. Hope you guys are all doing well. Before we jump into today's video, I want you guys to do me a favor. Go and smash that subscribe button. That way we can break the YouTube algorithm and get this video out to more viewers. And if by the end of today's video, if you guys find this information useful and or helpful, go ahead and hit that like button, turn on notifications so you know when I'm uploading new content like this. With all that being said, let's jump right into today's video. Alright guys, so in this video I'm going to be taking a look at a 2009 Honda Civic. Customer's complaint is the AC system is not working. So I actually noticed two things with the AC system. A, the blower motor is not working when you turn it on and off. Obviously turning it on, it should spin and it should allow air to come out the vents. So there's that problem I'm going to have to take a look at. And there's also a noise, almost like a grinding sound coming from the engine bay itself. I already flipped up on the hood, I already took a peek around, and I determined the noise is coming from the AC compressor. I will show you the noise and I'll show you how I basically determined it. You can kind of determine it by feel, putting something on it, and you can also by ear, by putting something on it and listening to it. So I'll go over that. We're going to look up the blower motor, but I also noticed check engine light is on. Not sure if these cars have a HVAC module where it throws codes if there's a fault in the system. So obviously I'm going to hook up a scan tool. I'm going to pull any codes. Maybe it'll determine why the AC system isn't working as far as the blower motor goes. Maybe it's shutting itself down. So yeah, let's go and hook up the scan tool. Let's pull the codes and let's see where we're going to go from there. So the scan tool didn't point anything towards the AC system. It's actually a catalyst system efficiency code, P0420. The customer probably already knew about it, which is probably why she didn't specify that the check engine light was on. Probably somebody already told her that she needs a cat. Maybe we did, I don't know. The other codes in there are for the airbag system. I have one for the ABS, and then I have a bunch of them for the tire pressure monitor system. So as far as the check engine light goes, I'm going to go ahead and ignore that. We're going to go ahead and look at the AC system. First thing I'm going to go do is I'm going to look up the wiring diagram. I'm going to see if the blower motor is either power or ground controlled. What I mean by that is there power there all the time and the switch is controlling the resistance on the ground, or if there's ground there all the time and the switch is regulating the power that goes to it. That's kind of important to know how to figure out if it's a circuit problem or if it's a blower motor problem. Once we get there, we can also undo it and we can go ahead and basically apply power and ground, and that should make the blower motor run all the time at full speed. So that will at least point towards if it's a harness problem, connector problem, switch problem, or actual blower motor itself. So let's go ahead and look at the wiring diagram and let's see how this thing is controlled. Alright guys, so let's look up the wiring diagram. Let's see how this thing is controlled. We have, there's the AC heating and air conditioning right here. So we're going to be looking at accept hybrid. And then what we're going to be looking at is a blower motor. Okay, so we want to see this one. Alright, so we're going to have a blower motor relay. So basically it's ground controlled. So we're going to have power coming in all the time. As you can see with this marked wire right here, power is going to be consistent. So as long as we have battery voltage here, then we're going to go ahead and check. Where is this at? Blower motor transistor on the right side dash. There, blower motor. We can also check the ground wire here. Make sure we do have ground present. So basically what that does is when it's in full speed, it's going to have no resistance and it's going to kind of go all the way back. And then we have the heater control panel. So this is going to be the switch right here. Okay, so let's gain access to this section right here. Let's see if we have power going to the blower motor, and then we'll also check for any kind of ground when we are running the circuit. So the blower motor is sitting right here under the dash. So there's the connector is really easy to see. Once you peek underneath, there's actually supposed to be a plastic cover right here, but I believe this car was at a previous shop and then they brought the car here. So this little plastic cover is actually not here. So what we can go ahead and do is unplug it, turn the key on, and then we're going to see if we have power, which we do, and we have ground. Okay, so what I'm going to go ahead and do now, I'm going to see what type of connectors I need, which they look to be female spades. So what I'm going to go ahead and do is I'm going to get 2 female spade connectors, and then I'm going to go ahead and hook up power and ground to the blower motor itself and see if I can get this thing to spin before I look any farther. So I got 2 alligator clip wires, my 2 green ones. So what I'm going to go ahead and do, because I don't have a spade connector that fit in there, I'm just going to clip these on there, make sure they don't touch one another. So we're just going to grab one on the very edge of it, and then we're going to use the rubber sleeve to keep it from touching, and then we're going to connect the other one on the other end of it and make sure that it doesn't touch. Okay, obviously if they touch, then my meter will blow its own fuse, and no harm, no foul there. So we're going to go ahead and connect it here, connect it to the ground. Okay. So now we're going to go ahead and test it out and see what happens. So we're going to send power. And it blew my fuse. They might have been touching. Let's try this again. Doesn't feel warm like it's a short though. Seems like the motor itself might just be shorted out. Let me see if I can get underneath there a little bit better. Give me a second. Let me get in there and let me get a good connection on it. There it is. I don't know why it's not grabbing this side. There it goes. Okay, we're good there. Let's try it again. Okay, we're going to try power again. I don't feel no heat. Yep, okay. So what we can go ahead and do next is test for any resistance in the motor. So we're going to use the same power probe. I'm going to put it on ohms. I'm just going to touch it together, see what my, so 0.1 is what we have with just the wires connected together. So let's try this again. Let's get that on there. Okay, there's one. And let's do number 2, which is the second plug. So the issue on this one is this, since the connector is so close to the housing, it's kind of hard to use the clips in that area. Alright, so I'm getting 0.4. So there is some sort of continuity within the motor itself, but obviously it's not working. Okay. And then what I can go ahead and, let me see, what can I do next? Connector looks okay. So what we can go ahead and do now is I can go ahead and check the blower motor resistor and see if potentially that is the fault. But again, adding power and ground to a blower motor should get it to run. If the blower motor resistor is bad, then it should run with just basic power and ground. Since we don't, I can already tell you right now the blower motor is going to be faulty. I just want to make sure the control circuit is working so we don't have another problem. So let me go ahead and check the ground circuit just to make sure it's working fine. Alright guys, what I was going to go ahead and do is I was going to check the transistor. So it doesn't have a blower motor resistor. It actually has a power transistor. So it's a little bit different in how it works, but essentially it does the same function as it regulates the amount of current going through it. So it'll change the speed of the blower motor itself. A little bit different as far as how you test it. If you're going to test a blower motor resistor, it's going to have 3 resistors and they should have different ohms as far as how much it should go through it. Now, let me get the camera moved out of the way real quick. So when you're checking a resistor, you can go on the repair data and you can get the ohms for each resistor itself, and you can basically put an ohm meter across that to let you know, hey, you know, the high, the low, and the medium are supposed to be here, here, and here, but this is what I have, so you can determine if that resistor is bad. These ones are a little bit different, but I was going to go ahead and back probe the ground section of it, see how much power is going through it. We should have a voltage drop that goes through it, and obviously as you go lower in speed, it should be a higher voltage drop, and then as you get higher in the speed, it should have the least amount of voltage drop, as it should just get full power going right to the ground. But when I plug in the blower motor itself, I don't know if you can hear that, but it started working. So yeah, check in the blower motor, full speed works. It does seem to be regulating. So the transistor obviously is working because it's regulating. And then obviously by me sending power and ground to that blower motor, it probably was enough just to get it working. So more than likely the blower motor is going bad. And by me sending full voltage, full ground, getting to try and work full, it jogged itself to where it started working again. I didn't do anything on the harness side. I didn't check for, all I did was check for power. I didn't do anything on the resistor or on the transistor just yet. I didn't play with the connector. I didn't back probe it yet, so I didn't fiddle around with that. So obviously there is a problem with the blower motor itself. So what we're going to go ahead and do now is we're going to shift to the underhood of the car, and I'm going to show you how I found, as far as the compressor being bad, I'll show you what I found and what I hear. Alright guys, so I don't know if you can hear the noise, but if you're doing this at home and you have a noise like this coming the underhood and you don't have a mechanic's listening device, whether it be a mechanical one like a little stethoscope or the wireless ones, you can use a long screwdriver and basically probe around it and just listen to it, and the noise will basically go through it and you'll be able to hear it. So in this case, I can actually feel it on the AC compressor. Let me put the mic through it, you can hear it. And then when you probe it anywhere else, the noise is gone. So yeah, so there's a noise coming from the AC compressor. Alright guys, so there it is. So as far as the noise goes, obviously the AC compressor is bad. Something inside has basically failed. When you're listening for noises on cars, ideally you don't want to use anything like a screwdriver, but you want to use some sort of listening device. But in the odd chance that you don't have one, say you're doing it at home, if you're a shop technician, you should have an actual listening device to listen for noises like that. But again, if you're doing it at home and you have a long screwdriver, it will work. Especially if you have one that has the shaft that goes all the way to the handle, that's mostly like the hammered ones, you'll hear the noise pretty clear. And a noise like that, like a grinding, you're going to actually feel it vibrate through the actual handle. And obviously as you go further and further away from whatever faulty parts you have, whether it be a pulley, a component, water pump, alternator, AC compressor, as you go farther and farther away, the grinding or the vibrations should go down lower and lower. Once you get to the actual faulted component, obviously it's going to be really loud and it's going to be really strong as far as the vibration goes. So this car needs a AC compressor. Now, when you have an AC compressor like that is grinding, it's going to have a problem where you might have metal debris that goes through the system. So what we're going to go ahead and have to do is we're going to have to flush out the evaporator, and we're going to actually have to flush out the condenser. If the lines do show that there's a heavy amount of metal, say when you pull it out and you check the oil and it's just silver metallic-y, then you have to start thinking about possibly replacing the condenser and the evaporator, but you can back flush them if you have the right tools. You want to get most of that metal out, flush out the lines. There's solvent that they do sell to flush them out, because last thing you need to do is you need to go put in a new compressor, put new oil. There's metal stuck in the evaporator or the condenser that cycles through the compressor, and the new compressor has a premature failure going through it. It's just a matter of time before it goes bad. So flushing out is an option, but to get everything out perfectly, then replacement is the most common option. You know, whenever you have a AC compressor that grenades, is what we call it, you want to replace them. But you can flush them out. Ours, we end up sending them out to a radiator shop. They clean them, they flush them, they cycle them out, and then they give it back to us almost brand new. As far as the lines go, we have a solvent can that we can run through it. It's a pressurized can, and we get all the dirt and debris out of it and make sure they're dry. As far as your blower motor goes, when you're testing those, fairly easy. They're usually just 2 wires, power and ground. So what you want to go ahead and do is you want to get a power probe, or if you don't have one, you can physically remove the blower motor. It's usually 3 or 4 screws that hold it on. It comes right out. Get it under the hood, get two alligator clips on both sides of 2 wires. Clip them to the battery, power and ground. Be very careful not to touch these wires on anything else. Attach the power first. That way you have that hooked up. And then go ahead and attach the ground, and it should spin. Obviously, it's a blower motor. It is a fan that's spinning, so keep your hands away from it. Ideally, you don't want to run that route because you can touch the 2 wires together and end up, messing up other parts of the car. So ideally, a power probe will work. If you can get 2 female spade connectors that fit into there, that will slide in. You get 2 wires that go to the power probe. That way everything is insulated and you have no problems of just random wires touching each other. But again, if you're doing it at home, be very careful. You can do it with just 2 wires, but you want to go really slow. You want to make sure the wires don't touch one another. Alright guys, so that's going to go and do it for today's video. If you found something useful in today's video, go ahead and give this video a like and a share. And also, if you guys have any questions automotive related, you guys need wiring diagrams, second opinions, or just a tip on something, feel free to hit me up on Twitter. I can respond to you guys via DM. Until I see you guys in the next video, you guys have a good one.